Okay, so let's go to full screen and okay, we have about 2 more minutes left before we begin. We'll give it another 2 minutes and then we'll jump right in. How's everybody doing this morning? Good? All right. A little tired? It's 9 o'clock early for you? Yeah? All right. I have no input into the decision about when the class is. So if it were my choice, I'd say 10:30, but I have a 10-year-old that drop off to school in the morning before coming here. So I can understand. My day begins at 6 o'clock in the morning. Okay. And so I haven't ever been inside of this classroom before. Every time I tried to come here to check out the classroom, there's been a class or a meeting here. So I imagine this particular classroom is very, very popular for intro classes. So 8:59. Why don't we get started? Okay, so welcome back and Happy New Year. Did everyone get the email through Canvas? Okay, great, great. Like you, I am also learning Canvas. They didn't give faculty much a choice. So after using Moodle up until grades were due last semester, we had all but 2.5 weeks or so to make the pivot to Canvas. So we'll all be learning Canvas together. And so I like to run my courses entirely digitally. And I like to also record my lecture modules for various reasons. But those recordings, while I make them available on the Canvas site, I'm so used to saying Moodle, it's not a substitute for attending class, okay? And there is a class participation grade. And so this is Intro to Data Science. And my purpose today is to introduce the course, talk about some course mechanics, some course policies, as well as to motivate what we're going to study for the next 15 weeks plus spring break. But before we begin, some administrative bits. And I like to walk around, right? And this class doesn't afford me the ability to do that. And so the folks in the front are probably going to get picked on a little bit more, but hiding in the back is going to bring attention to you, and I'll call on you. I'll call on you certainly. And so I like to have administrative slides for each one of my modules so that you're always kept aware of what is due next and what the reading is. And in this case, the reading is the first chapter 1.1 to 2.4 in the main text for the class. And so this text, you can purchase the book itself if you choose to. It's also open access, and my philosophy is to try as hard as possible not to participate in the mild extortion that is textbook prices. And so a lot of things in this class will be curated from various sources and made available in the course references section of the Canvas site. And so I encourage you right away to please go up on Canvas and familiarize yourself with the setup of the site for the course. I distribute homework and collect assignments and homework and administer my written exams entirely using the course management system, Canvas, this semester. Any questions? No questions? Okay. And so project one, I will be posting after class. It will be due a week from tomorrow. Hopefully I've calculated that correctly. And my style is to have assignments due 1 second before midnight. Please make sure when it's posted that you are looking at it right away. And the purpose for this first assignment is to kind of get you a little bit more familiar with Python. Show of hands, did anyone, you all took 120? Or did you take the 301 version? No? Okay. And so I'm not sure how they taught you 120. So I like to begin this course, and I taught it last semester, with an exercise to kind of get any sort of rust off of your Python practice. And this is not a Python programming course. That's not the purpose of the course. And for those of you who are computer science majors, it's not a science course. It's a data science course. And my design for the course takes from what a lot of universities around the country, and I used examples from 12 different universities, big ones, small ones, public ones, private ones, community college, Ivy League, and so forth, to cover topics, sampling across key topics for data science to hopefully turn you into mini data scientists, so to speak. And so right away, you should be looking through the material on Canvas, and it will rapidly populate with a lot of things, especially the course resources section. You should register for and join Slack channel. I use Slack, a messaging system, as the primary means of communication. You're welcome to send me email about things, but I prefer you use Slack, and that helps me to help you better. I get about 100 plus emails a day about all sorts of things. People sell you stuff and all sorts of asks and things like that. And unfortunately, sometimes I miss emails. And so Slack allows me to better manage all of those messages, particularly the questions and clarifications you might ask pertaining to the assignments. The teaching assistants will also be on Slack, and they will be setting their office hours, and we'll talk about that in a few moments. Read the syllabus. That is my contract with you. It outlines my policies for the course. I'll go over some of them today, but I'm not going to go over them in detail because one of my goals today is to try to get to know all of you a little bit better. Granted, at the moment, there are 24 people registered for the class, and so there are more of you than me. I admit I'm very, very bad with learning names. I'll remember everything about you, what you like to eat, where you went to vacation, where you live, all that stuff, and forget your name. So please help me to understand your preferred name. Okay. Is that a deal? All right, great. Thank you. And also, please make sure you look at the course resources for installing and running Anaconda and PyCharm. Now, the setup for this class, Monday meeting and Friday meeting are the sort of lectures, and Wednesday is the lab. But I'm going to use today as a kind of lecture module and use Friday as lab because it's kind of weird to have a first day be a lab. Okay. Are there any questions? No questions? No? All right. And so because it's a data science course, I thought I would collect the data, and the course roster has increased by 1, but this does not reflect that. And this first slide along the horizontal axis, these are the different majors that are comprising the cohort for this semester version of the class. And along the horizontal axis, we have the different majors represented. And on the vertical axis, we have the frequency that counts. And so certainly because it's a data science course, the majority are data science majors, but we have many undeclared majors. And so those undeclared majors, I'm going to try my best to get you to sign on the dotted line for signing up for data science major, minor, computer science major, or minor. And so in today's modern age, regardless of what your field of study is, it's almost unavoidable that you're going to deal with data in some form or fashion. And at a minimum, having those skills and tools, so to speak, in your toolbox to allow you to make statements, principled statements about data is very, very important. And so if you never decide to implement an algorithm for analytics or extracting insights from data, you're certainly going to have to deal with data in some form or fashion. And so at a minimum, data literacy is very, very important, especially for your generation going forward. Any questions? No questions? All right. And so when we look at the status, we have first years on through grad students. So we have a good mix of people. But if you look at the 2 tallest bars along the horizontal axis, we have the status. On the vertical axis, again, we have frequencies. Sophomores and juniors represent over 50% of the course enrollment. Okay, well, that's pretty good. And so in this course, I'm going to try to pivot you from being a student into being a researcher, right? There's a different set of skills, and the type of problems that I like to give are probably a little different from what you're used to, especially for the first years and the sophomores. Okay. And so we have 2 grad students, 2 undergrads, the majority of the class, or the simple majority, sophomores and juniors. And I'm going to assume Calculus 1 for this semester's version of the class. And there's certain tools from calculus that we're going to use, especially when we get to the portion on inference. Okay. Now, I'm not going to give it the same treatment as a calculus course. I might give a definition, but our goal is to enterprise to use it for the purposes that we have, specifically something called max likelihood estimation. Okay. Any questions? If you're a little rusty on calculus or you're taking calculus now, please send me a message privately, and I'm more than happy to point you to high quality resources to help you succeed. Okay. Any questions? No? All right. And we're also going to assume CS120 or equivalent. And so this is not a Python programming course. We will cover aspects of Python specific to the purposes that we're discussing, but we're not going to go over Python syntax and semantics. Okay, any questions? No questions? No? All right, no, quiet. So letting breakfast digest? Yeah, all right. And so I came from industry, and I had a career in industry, then went off to get my PhD, and then went back to industry, and then came into a professor position at a previous institution, and I've been here at Clark now for a year and a half. So what I'd like to do is break the ice and go around the room and ask you if you could give me your first name and just some thoughts about what you hope to get out of this course. Hi, how are you? Let's start with you. Okay. Okay. So analyzing, and can you say the name again? I'm sorry. Raina. Raina. Okay. I'm going to forget everyone's name. If you sit in the same seat each time, that'll help me. Right. Yes. Scott. Okay. Did you take stochastic with me? Did you take stochastic with me? Okay. Claire? Claire. Mm-hmm. Okay. Okay. So the coding aspect, analytics. Okay. How about you? One more time. I'm sorry. Tapua. Tapua. Mm-hmm. Okay. Okay. Tapua. All right. And you? Shafi. Okay. 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 How are you? And you? Ryan? Okay. 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 I did some work with Dr. Estes. How about you? Anna? Zanab. Zanab. Okay, analyze data. And how about you? Jake? Okay, so hopefully by the end of the semester, we'll get you to sign on the line. Okay. And how about you? Debrin. Can you say one more time? I'm sorry. Debrin. Okay. Okay. Mm-hmm. Okay. So we've already hooked you. All right. Yeah. All right. How about you? Okay. Okay. All righty. So we need to get you to sign on the line. How about you in the back? Mm-hmm. Okay. All right. Thank you. How about you? Mm-hmm. Okay. So I have to make the hard sell to you too. All right. How about you, Tanner? Mm-hmm. Okay. A lot of data in geo. How about you, Cecilia? Mm-hmm. Okay. All righty. How about you? How about you? Ashley. Okay. A lot of data. We had X majors last semester, so a lot of data now. All right. Thank you. How about you, Annabelle? Okay. All right. Did you get my email response? Okay. Great. How about you? I can say one more time, I'm sorry. Hello. Okay. Okay, great, great. How about you? Okay. Okay. I think you'll like this course. I know you'll like this course. How about you behind her? Hmm. Okay, so we need to get you signed on the dotted line. Okay. How about you? Okay. 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 They interact in very many interesting ways. All right. How about you? Hmm. Okay. Hmm. Okay. Great. Great. I was on the hiring committee for the data analytics professor that's going to start this fall. So, and how about you, Taylor? Hmm. Okay. Great, great. So lots of varied reasons. And so the big onus is on me to make it interesting, to make it relevant for you to really learn something. And my goal is to turn you into experimentalists, which is a little bit different, I think, from a lot of the courses many of you have had up to this point. And so I'm very fortunate this semester to have two TAs, and they are also students. They took the course with me last semester, and they're very, very talented young people. So I'm very excited and happy that I have them on the course staff. And because they're students, I will leave it to them to figure out what the hours are that they can serve for a teaching assistantship. And so I encourage you to use your resources, whether my office hours, which are on the syllabus, or their office hours, which are to be decided. Okay. And so a little bit about me. My PhD was in robotics, machine learning, and statistics, some distributed systems. And I had a career in industry for 8 years before leaving to get my PhD. And it was just sort of dumb luck, but I left right before the dot-com bust happened, right? And then after grad school, went into industry. I was a research scientist doing mathematical modeling mostly and machine learning from sensors. More recently, before I started in academia, I was doing machine learning on sensory modalities, which is my research for my lab here at Clark. And so I'm relatively new to Clark, a year and a half. I'm new to central Massachusetts, so I'm always looking for interesting restaurants if you have any suggestions. Um, and I haven't really used Windows in the last 15 years or so. I stick primarily to Unix for various practical reasons. So I'll try my best to help you with Windows. Elizabeth and Diana are more conversant in Windows than I am, to be honest, but I'm more than happy to help you succeed. And again, please help me to learn your preferred name because I will remember everything about you that you said and forget your name. So I apologize in advance for that. It's just one of those weird things that happens with me. Okay, so course outline, and I'm not going to spend too much time on this, but I think it's important to outline the goals and objectives for the course, in addition to the mechanics about expectations, assignments, and grading scheme, and all that stuff that I'm sort of required to go over. And so we'll talk about this thing that'll be a recurring theme, the quote unquote data science process. And this outlines a number of things that are important to data science. And if you go off into the marketplace and you look at positions called data science, a lot of employers have different definitions for what data science means. And so for us, the entire process involves first posing a question, obtaining the data. You have to go out and figure out what data you need in order to solve or answer that question that you're enterprising to answer. You'll also need to prepare your data. You don't just take your data in its unadulterated form. You're going to have to do something to it. And that something that you do to it is going to result in some parts of that data being stripped away and other parts of that data being preserved. And so every choice that you make is going to result in something. And my goal is for you to understand the tools that you have available, as well as the consequence of those choices that you make and what it brings to bear with the resulting statement and insights you're trying to extract. And so visualization is a really important part of it, because the data is telling you lots and lots of things, but you have to know how appropriately to ask it. What are you trying to tell me? And that visualization will guide your choice of what approaches, methods, and tools you use when you're enterprising to extract insights. And so this visualized data part is going to require some experimentation. What educated choice do you think is appropriate, and why, the important part in this class, why you made that choice? And as a result of that choice, what did you find? What does it mean? Do you need to change your choice? That's a really, really important part of this process. And the extracting the insights, that alludes to the models, the methods, machine learning primarily, that you use to uncover those nuggets of information that are meaningful within the data set that you, or data sets that you have. Any questions? No questions? No? All right. And so I hope over the course of these 15 weeks, plus your spring break, that I can also impart some of my enthusiasm for the subject material. As interesting as I can make it, there's some topics, okay, calculus might not be fun for some, but it's certainly a wonderful set of tools that give rise to a lot of powerful techniques. And this last part, reporting, is really, really important, because when you report on these insights that you extract, it's going to be really important to understand the audience to whom you're speaking. Because you might be speaking, for example, if you're in public policy or psychology, you might be speaking to a general audience that did not take data science. And it's really going to be important to articulate it well. So we're also going to give you opportunities to present and also talk about some strategies for giving effective presentations. That's really, really important. Moreover, on all of the project assignments, you will be writing, because it's important to practice articulation of the results that you bring to bear. Any questions? No? All right. And so we'll have a bunch of tools that we use to do this. The language of instruction, computer language that we're using, is Python. And in data science, there are two major languages that people use, not the only ones. And these are R and Python. And we've decided to use Python because our CS120 is also Python. But certainly you can do data science in MATLAB, in R, in Python, really in any language you choose. It's just that in Python and R, there are a lot of tools and tool libraries available that do all sorts of useful things that we're going to make use of. Okay? Are there any questions? No? Yes. Yes. You can use any environment you use, and thank you for the question, but I can support you on PyCharm. I can't support you on those. And so if you have a question about, well, how does Eclipse do this? Well, I don't know. PyCharm does it this way. Okay. So you're free to do that. But I would prefer something that runs in PyCharm, and we'll later use Jupyter notebooks, because that makes it easier for me to grade. Okay, because I'm set up with PyCharm. Okay, answer your question? All right. Any other questions? No? All right. And so I really hate this board because it should be lower down, because everyone's kind of looking up like this. And I should jump up and say, hey, over here. We'll also use Anaconda, which is a scientific library package system, really powerful, and it's used throughout the data science community. We'll be using Jupyter, which is a type of interactive digital document system. And Jupyter is a lot different from something like PyCharm. They both allow you to write, edit, and run code, but PyCharm is a debugger, right? It allows you to freeze the execution. Have you used debuggers in 120? Okay, so I won't talk about what a debugger is. Jupyter is an interactive notebook, but PyCharm is a debugger. And the two are purposed with different things. Jupyter is really good about allowing you to quickly view interactive results. And so that's important, especially when we're looking at the visualization part of the data science process. Okay, so, and we'll also have examples from many key APIs within the Python library, SciPy, scikit-learn, NumPy, and visualization APIs as well. So we'll also make use of probability and statistics, and we'll cover the relevant material as needed. And that's to get you thinking rigorously and a little bit differently about your data. And this will be useful, especially building up to our module on inference. Inference is the asking of questions, posing of questions to your models. And that's really useful for things like recommendation systems, for filling in missing data, all sorts of very useful things. We'll talk about populations and their summaries, which will kind of get us to the visualization component, because how you think about your data heavily influences the type of processing you can play on that data. And then lastly, reporting. We'll look at different chart types and look at presentation strategies. Any questions? No? All right. Take the time. So what else will we do? Ethics is a really big part of this. All of the implications of the statements you make, they're used to do all sorts of things. Many municipalities, including the city of Worcester, they're starting to instrument all sorts of aspects of how they operate, and the decisions made by them are used to marshal resources and implement programs. A friend of mine, Wendy Martinez, is the director of the mathematical statistics group at the Bureau of Labor and Statistics. And the data science work they do is used as the basis for making decisions by the Congress, the Senate, and the House. And so it's really, really important that you understand issues about bias, how that data impacts people, and it can happen without you planning it that way. Also, I want to give you a very scrutinizing eye towards any kind of summary. Is it meaningful and is it significant? The first question you should always be asking is, how did they design that study, right? Because I could say coffee increases student performance had an increase in student performance of 50% by giving them, 1 cup of coffee a day. And it could be that I only had 2 students and that performance increased for 1 of them, right? That's not very meaningful. So you should always look to the design of the protocol that led to the analyses when you look at results. Now, privacy is a really important thing. And if you're on Facebook, whether you realize it or not, if you're on TikTok, you're not their customer, you're their product. They're buying and selling your information, whether it's explicit information that you input, like your name and your location, or it's implicit things like your gesture, what you're clicking on, and what content you're viewing. And so it's really important to understand where this data comes from, what people do with this data, and to be aware about the implication of the results, the insights that you present. Okay. Any questions? That makes sense? Yeah. All right. And the practical part. I want to develop in you, by the end of the semester, an experimentalist skill set. Right? Data science isn't like other courses where there's a more prescriptive approach. You're going to have to make choices based on what you see in your data. Right? It is truly experimentation. And for some of you, that's going to be very different from other classes that you've taken. For others of you, it's going to just kind of fall right in and be very comfortable. And so it means that you're going to prototype things, you're going to engage in a series of design iterations where you're testing things, look at the results of those outcomes, and use that to guide your decision. And so at the end of it all, it's not about, quote unquote, the absolute right answer. It's about the tools and components you bring to bear, the answer they give you, but why you chose those particular tools. Okay? Any questions? Does that make sense? Yeah? All right. And so in the 15 weeks of the semester, data science is a huge field and it's continuing to grow. I can't teach you every single detail. And so my approach is to survey various key topics and give you some examples within each one of those key topics. And so my goal also is to, quote unquote, teach you how to fish, right? To enable you to be able to go out there and look up further things of your own accord, right? That's really, really important. In fact, things that weren't there last semester are now out this semester. So just on a month-to-month basis, there are always improvements and additions being made. And so keeping a research notebook is going to be really, really important, or an engineering notebook, to be able to assemble your own sort of curriculum of topics. And for some of you, that curriculum will be different, because perhaps if you're filling in some aspects of calculus, you're going to have that on among the materials that you bring to bear. Also, be a good team member. The days of the solitary software engineer working in the back room are over, right? So I encourage you to work in groups. And in fact, on my projects, I allow groups of a maximum of 2. And so that means also being an accountable group partner to your colleagues in the course. Any questions about this? No questions? Oh, really quiet. All right. And active participation. There is a class participation grade that's 5% of the course. I really encourage your participation, and sort of the litmus test for that is that if I have no idea who you are at the end of the semester, it's probably not going to work out. I really encourage you to actively participate. I want to hear what you're thinking, how you're doing, your thought process as I bring you into this more experimentalist type of doing work. Okay, any questions? No? All right. And so this is the textbook. We're going to supplement this with a lot of things. And my previous offering, I had about 4 books, and we ended up using bits and pieces from many of them. And so the approach I'm going to take this semester is to frame things from stuff in this textbook, but also provide lots and lots of supplementary material on the course Canvas site. Okay. The textbook, you can purchase it in paper form if you like atoms. The textbook is also open access. There's a website and course resources on the Canvas site where you can access it for free if you choose to. I tend to like paper, but maybe I'm old-fashioned. All right. Any questions? No? No? All right. And so there are other useful resources on the web, lots and lots and lots of things. But I encourage you, when you use these resources, don't just copy and paste, understand what it's doing. And I ask that you cite your resources, cite your sources, so that there's no misunderstanding about academic honesty. Okay. Any questions? No? Wow. All right. I'll get you talking by probably next week or the week after. I try as much as possible to sort of make the distribution across the different assessment types as close to uniform as possible. And so we have projects, which is a very large component of the course. We have the written portion in exams, which I usually have as take home that are timed, as well as 2 written assignments as homeworks. The final exam for the course is a final project, and it's a comprehensive assessment for a real analytics problem where you're going to be doing reporting, you're going to be coming up with your own questions, you're going to be choosing analyses, and you're going to be interpreting those insights that you obtain and making a recommendation for something. Last year, our final project was a scenario working for SoFi Technologies, the personal finance company, and we studied Media, Pennsylvania, a real town outside of Philadelphia, and we looked at financial data, and the result was a recommendation of financial products to benefit the population of Media. And I don't know if anyone's from Media, we just chose it. We're going to choose a different city this year. You're from Media, okay. A lot of very interesting results people had. Any other questions? Yes. I won't go over that now, but I will give a rubric for evaluation to tell you about the specific scoring criteria, and also give you lots and lots of modules and pointers on effective ways of making presentations. So we'll get to that in due time. This is sort of like these cooking shows. I show you the result first before I cook it. Okay. Any other questions? Yes. The written assignments. The written assignments are the homeworks, which are generally a little bit more mathematical, and the written exams, and those exams are not cumulative. I like to give exams that talk about material for the first third of the course and roughly the second third of the course. And then the final project involves a large written component. In each one of the project assignments, and thank you for asking, you're going to have a written component, including a reflection. What did you learn? How did you go about doing this? But also what choices you've made, what you found, and the results of the insights that you've extracted. So there'll be lots and lots of examples of or opportunities to write, but the pure written components are the homeworks and the project report on the final project. Answer your question? Any other questions? No? No other questions? All right. And so I do absolute grading. And so your efforts are focused on beating the grading scale and not beating one another, right? When I was an undergrad, there was a really, really unhealthy environment in the engineering school at Tufts University where, the class would kind of need someone to fall on their sword to kind of help the others on the curve, right? And that was very unhealthy. So I thought back then, one day I'm going to be a professor and I'm going to do absolute grading. So here I am, right? So I encourage you to get your PhD, become a professor, and run it the way you choose to. And so I'm not going to go over the grading scale. I'll leave it to you to look at the syllabus for that, but it coincides with Clark's grading scheme with pluses and minuses. Culture credits. This is a thing that I brought from my previous institution, and it was a way to encourage students to participate in professionalism activities. Now, certainly your students of your discipline, all the technical bits, you also learn something about yourself in college, but it's really important to learn about your field, right? Don't leave it up to chance, especially now, you're young people, things are changing very fast. Understand your discipline. Fortunately, in the computer science department, there are a lot of activities. They have speakers, student project presentations, seminars, hackathons, and things like that. I really encourage you to participate in that. And so one of the things we instituted was something called a culture credit, where you get a document, almost like a stock certificate, and you can spend this with various faculty. Not all of my colleagues will accept them. I know Dr. Story accepts them, I accept them, and I think Dr. Hahn accepts them. And I use them specifically if you are borderline to give you that boost to the next grade up, right? And I have a very specific definition of what borderline means. Okay. And so if you participate in that, you'll see different seminars. I will accept the culture credits, and that's how I use them. Question? Okay. For me, 4 to 6, depending on the event, and borderline is less than 1 point to the next grade. And so I will also tell you, if you come to me with the culture credits, I'll tell you if that makes a difference. Many times for a student, it won't make a difference, right? Sometimes it does. Okay, so I'll calc the grades and let you know, if that's you being everyone, not just you. All right. Any other questions? No? All right. And so my approach, I don't believe in memorization. I don't believe in repetition. I think it's a useless exercise for you to memorize and regurgitate back the information. People forget about 60% of all the details of what they learn. But what I do hope to endow in you at the end of the semester is open-ended problem solving. Now, in the beginning, many of my students, they probably don't like it. And towards the end, some of them don't like it. But every semester, I get those emails, oh my gosh, I didn't realize how valuable that was, right? And so whether you like it or not, the ability to make your own choices is going to be really, really important, especially when you're dealing with data analysis. So one of the projects that we're going to have is to look at actual municipal data from the city of New York, the taxi and limousine commissions data. It's big data, deals about 10 gigabytes of data. And with that analysis, one of the things you'll be asked is to determine if ride-hailing services like Uber, Lyft, and so forth are fair relative to the traditional yellow cab industry, right? And so one of the things I'll ask you to do is to pose the question by looking at the different principles involved in that problem, and given that question, to design the analyses and do the visualizations to arrive upon what sort of insights you're enterprising to extract, then to implement them and to extract them. And so some people, they'll ask me, if I do this, this, and this, is that okay? Well, why are you doing those things? And it's a different way of doing an assignment, but what I really hope to instill in you is the methodology of making these informed choices. There's no one way to do it. And of course, consequently, it doesn't impact you, it impacts me. It's a lot harder to grade these things. It takes a long time. And so with this, I do what's called inquiry-based learning. I don't give you memorization and regurgitate types of things. Give me the definition of this. I think that's a useless exercise. I want you to be conversant in the data science process and conversant in how you appropriately select the tools and justify that selection in order to do your analyses. Okay, does that make sense? Any questions? Now, this comes from my background in industry. When I was a research scientist at Lockheed Martin, you were given a general problem and you had to come up with questions to ask about the problem and design a whole host of things to decide and tell your clients what it is you're enterprising to do and why. It's a really important skill. Any questions? No? All right. And so people ask me how to succeed in this class. It's all about engagement, right? Doing something every day. You don't have to spend hours upon hours, but doing something every day, right? That slow churn is really, really important. Ask your questions, use the discussion forum, use Slack, and we'll also draw from several sources. So please do look through those sources. I spend a lot of time curating these things, and I'm very enthusiastic about your success. Okay, right? Any questions? No, no questions? All right. Oops. Spend time every day. And a friend of mine who works in the finance industry, I borrowed his quote, I don't need Superman, just be Clark Kent, do your job, right? What I mean by that, don't stay up all night doing something, right? Get on the assignment as soon as it comes out, spend the time understanding what it is and what it means, and do something every day, right? Some days it might be more, some days it might be less, okay? But in the limit over time, it adds up to something significant. And I promise you, you will surprise yourself in a good way. Any questions? No? Okay, and so policies. Please be here on time. Yes, question. Yes. I like to give about a week for assignments on the calendar with a little bit of a breather in between. And so I try to synchronize it to the lab session so that you'll be prepared to do the assignment. Any other questions? No other questions? Okay. So please message me if there are issues. I understand that life gets in the way, and I've helped out students to the best of my ability with all sorts of things. If you cannot make the office hours, I'm more than happy to arrange something with you by appointment. Please just email me or Slack me, more so Slack me, because I'm more than happy to help you succeed, but you have to help me to help you to succeed. I don't accept late work, never have and never will. I'll give you ample time and I'll give you ample resources, both in class and in lab, to help you to be successful on it. And so, you know, again, there are some issues that happen and I understand that. More than happy to work with you, but please make sure you budget your time and you get things in on time. If things are late, what it does, it holds me up from being able to go over solutions, and also you're not keeping up with the pace. And it's really important that we cover certain topics as a scaffolding to prepare for other things, right? Most of my students, 100% of my students are very successful. So my policy is not to accept late work. Once the deadline is reached, the submission target and the learning management system goes away. So if you go on and you say, hey, well, it's not here anymore, that's because it's now expired. Any questions? No? Please do not email me assignments. If there's an issue, reach out to me. I'm more than happy to help you. When you send me email attachments with zip files, you blow up my email quota, and you deprive me of the ability to accept other emails because my mailbox is full. I'd rather you use the submission system where they have the storage quota in place to upload all of that information. Okay, and please, if there is an issue with something, don't copy something, don't cheat. It's painfully obvious if someone is copying something or cheating or engaging in academic dishonesty. You won't enjoy it, I don't enjoy it. It's nothing personal, but I still have to do my job, okay? Now, your programs, When you write your program, I expect it to compile and run. I reserve the right to just score it a 0 and just move on. I'm not going to debug your code. Ask me questions before it's due. I'm more than happy to help you succeed. But don't hand in something that doesn't run. Question. You run it, and you can use a debugger in the notebook. You can execute it. I personally look at every line of every program. It takes me a significant amount of time. So please make sure you write something that runs. But to answer your question, you just run it. And if it runs, I'd rather you hand in something that runs, that only partially implements, not you in particular, than to hand in something that just doesn't run at all. And so that includes when you make a submission of a project, that submission should run as a contained unit. Don't assume that I'm going to provide the data file for you. If I furnish a data file with the project release, I expect you to include that data file in the submission. It has to run unadulterated, right? There are 24 of you, and I spend significant time doing the grading. So please also make sure you're following instructions and make sure your submissions are complete. Any questions? No questions? Yes. It's hard to do auto grading for these sort of problems because I can't make an assumption ahead of time which machine learning method you're going to use, because we'll cover about 5 of them. And so for that reason, there's no auto grader. Now, if you're looking for checks and you're looking to see, okay, does this run? One of the things I recommend is before you hand in your archive that contains your project submission, that you de-archive it, and then whatever you de-archived or unarchived, you run that thing before you push the button and submit. I do allow you to submit multiple times. I think it's set to like 20. I won't grade any of the intermediate ones. I'll only grade the last submission. Yeah. Answer your question? Any other questions? No? All right. And so I go over all of this, not because I'm sort of a control freak and all that other stuff. I go over this because it really helps me to run this course effectively. All right, I value a distraction-free environment. When people have side conversations, if you have something burning to express, please share it with your colleagues in the class. It's obvious, and it also takes away from everyone else's education. Okay, any questions? Yes.
Is code also graded by design?
Is it graded by design? Yes. There are some, I won't say, okay, did you use your curly braces this style or how your variable names? I ask that you try to make it self-documenting and choose good names for things because it makes it easier for me to grade. But this is not a software engineering course. I will check to make sure that, did you implement your max likelihood estimates? Did you perform sampling, etc.? But I'm not going to look at your style. Certainly, you should have comments in your code at this juncture because it's just good practice, but I won't be looking at that aspect of style. Okay? Yes. And on each assignment, I give you the points total. 20 points will be for this, 10 points will be for that. So it'll always be clear how I arrive upon your score. And I also have a rubric that I post for projects as well as for homework. Any other questions? Thank you for asking. Yes. I usually don't. In my career, I've probably granted about 6 extensions. One student in the previous institution had kidney failure. Another student had a house fire. Another had jury duty. Another had National Guard service. And so I usually don't grant extensions. I ask that people contact me early and I will help you to succeed, right? And I give you everyone ample time to complete the assignments. Any other questions? Does that make sense? All right. So I'm here to succeed, and my TAs, Diana and Elizabeth, are here to succeed if you let us, right? And the if you let us part, I say that specifically because oftentimes students don't come to us or reach out until there's a problem. Please don't wait until there's a problem. Make sure that you are communicating early and communicating often. Now, this last part is pretty serious. Do not struggle in isolation. Everyone comes to college with different backgrounds and different pressures and concerns and things like that. And, I was reading a couple years ago, this is back during COVID, I was at my previous institution, and the statistic floored me, right? It said 1 in 4 of every college-aged adult, 18 to 24, has had suicidal ideation, right? Now, mental health is health, and there's absolutely no shame in asking for help, and I really mean that. And some students have reached out to me here at Clark, and certainly at my previous institution. I'm not licensed, nor am I qualified to deal with these sort of issues, but I can point you to resources on campus who are, right? And so please do not struggle in isolation. There is no shame in asking for help, and take your wellness and your well-being very, very seriously. Things happen in life, and there are seasons of joy, and there are seasons for sadness and things like that. And there are lots of things people go through. But please, please, if you're not comfortable reaching out to me, certainly my chair, other faculty, more than happy to help you or direct you to resources in that regard. Any questions? No? All right. And so COVID. Certainly, I won't go over the whole policy. The university has a policy, and faculty are able to set a masking policy. My policy is that I won't require you to wear masks. I personally wear a mask for personal reasons having to do with my elderly parents, right? But certainly, if you are sick, please do not come to class and get other people sick. You're welcome to join the Zoom session live, and also welcome to look at the recordings. I like to record things for various reasons, so I can archive and, look back at what I said and how I said it and things like that. Okay, any questions? No? All right. So let's get to the heart of the matter. We have 25 more minutes. What is data science? Now, certainly a lot of you said you wanted to learn more about analyzing data. One said you wanted to know about machine learning. One said you wanted to look at some of the programmatic interfaces and how you implement these things. And there are a lot of things along that general sense. And so the modern world is rife with data. And more, regardless of the discipline or domain in which you're engaged, you're going to have to deal with data. And so I'll direct your attention to the upper right-hand corner. That's a smart meter. And I remember when I first moved to Delaware back in 2006, wow, it's been a long time, they were converting over most of the residential electric delivery to smart meters. And these smart meters get their name because not only are they measuring the amount of power consumption, they also implement inbound controls where the power company can throttle up or throttle down the amount of power you're able to consume. Now, the reason for doing that originated with this problem that many power grids had during times of peak demand, like in the middle of summer when everyone has their air conditioners on. You get brownouts, and what would happen is that entire swatches of municipalities would lose power because the demand for power exceeded the supply being delivered through the infrastructure. And so with these smart meters, not only do they look at your consumption, you can also use them to control how much energy people are consuming or able to consume. And in doing so, you prevent these brownouts, but everyone is only able to use a little bit less power. And so with this, you can look at trends, both in terms of time as well as geography, and make all sorts of statement about patterns of access to power. Now, what can you do with this information? Let me ask you. If you knew how much power was being consumed and when, what would you do with this information? Just calling you in the back. What would you do with this information? I'm sorry? Mm-hmm, mm-hmm, mm-hmm. So you can use it to prevent things from happening. Okay. How about you? How about you? What else do you think you might add to that? Anything to add to that? You can use it to prevent things from happening, these brownouts. Mm-hmm. Okay. Okay. So this thing called provisioning. right? You can, with knowing when and where energy in certain amounts is going to be used, you can ahead of time predict it, and then enterprise to recruit these sources so that it'll be available in the places you need when you need it. Okay. There's another one. Let's look at the upper left hand, where we have this kiosk, this point of sale system. And with this point of sale system, not only do you have the sales coming in of various food items, you also connect this to your inventory so that you know what levels of product that you have at certain times of the day, certain days of the week, months of the year. So let me ask you, what do you think you would be able to do with that information? How would you use that? Mhm. And why is that useful when you restock items? Why might that be useful? So let's ask you. Uh-huh. Mhm. Yes. And so the stock levels and the seasonality. And the stock levels are important, especially for so-called perishable goods. If you buy certain items, food items, fresh foods, you can't just keep them in the freezer as long as you want. They expire and you have to get rid of them. You have to discard them. And the seasonality represents how that demand changes over time. For example, in a coffee shop, you might have the morning rush early in the morning. People get the coffee, Dunkin' Donuts, Starbucks, wherever. Then there's a lull in the amount of customers that arrive. And then right around lunchtime, it peaks again. And then there's a lull. And so this seasonality doesn't just refer to the time of the year, it also represents a rhythm, as it were, throughout the course of a day. And knowing this seasonality tells you lots of things, both in terms of inventory, but if you think there's a lot of demand at certain times of the day, you can also use that to drive how many employees that you're going to have. Because the largest cost to a business are the employee costs. And every dollar that you pay an employee, you pay about an additional 50 cents in the benefits, the health and other things like that. And so with that, you can use data instead of just making an educated guess. You let the data tell you about the peak times, about the slow times, et cetera, in addition to your inventory. Okay, another one here on the lower left-hand side, your left, we have a bodysuit and it has sensors embedded in it. Now that's part of this movement called quantified self. And it's based on the idea, and we're starting to see this already, that individuals take up the responsibility of their day-to-day health. And many a physician will tell you that they would really like to see your everyday health statistics that include things like blood glucose, heart rate, respiration, core temperature, all sorts of measurements. And so with this, imagine you wear something like many of these watches do now, and this thing gets your vitals. So then a physician with some analytics can come in and say, gosh, your heart rate is really elevated during these times of the day. Now, one of the interesting things about that is with this idea of elevation, you're trying to measure this notion of irregularity. And how do you define irregularity? What tools do you use? What are the idiosyncrasies of those tools? And along what time scale is appropriate? So there are lots and lots of types of data questions that one would ask with this, as well as all of the other examples. Okay. Any questions? No? And so my research is in intelligent sensing. And I like it because a lot of interesting things happen, rich and messy problems, when you interface with sense phenomena, i.e. with the real world. Okay. And there are lots of tools we can use, and we'll cover some of them, not all of them, among our topics that we're going to study this semester. Okay, any questions? No? All right. Oops, and my clicker just went dead. There we go. So awash with all this data, one of the key questions is we have data streaming in on one side, and we want to extract those salient parts of the data, the insights, that's going to tell us something about the system that is being instrumented. What does the data tell you from all these smart meters for particular geographies or municipalities? What does the data tell you for this particular person relative to a population of cohorts of some sort? What does the data tell you about this restaurant group, geo-index, in terms of where it's located relative to all the other similar types of restaurants or concerns in the area. And so the sense making of data is what the purpose of this course is. And again, we're going to survey examples within key topics for the data science process. And so the first thing you do when you have your data is you look at it. The data wants to tell you a story, but you have to know what questions to ask it. And asking the right questions of your data is one of the key aspects of how you arrive upon the insights that you extract. But you have to look at it. There's no substitute for looking at it. But when you look at it, you have to know how to look at it. And there are various methods for looking at it, the unadulterated data, as well as processes that you apply through your visualizations. Now, of course, every visualization that you make is summarizing. And with these summaries, you're going to lose some parts of your data and you're going to highlight other parts of your data. And knowing which things are important to lose and which things are important to highlight when and why is going to be a really important thing, certainly that we'll cover throughout the semester. Okay, so then you apply your models. A model can be many different things. It makes a certain assumption about your data. And this particular model that I'm trying to depict here visually is going to associate data items, datum, with one another, clustering. And so that's useful for all sorts of analyses. So imagine you had a bunch of images in an image database. So, you carry on your camera phone, excuse me, and you take lots of pictures. You don't want to go through thousands and thousands of pictures trying to group them together. You want a system to come up with a model, or you come up with a model for the content of an image, and then you let the system group them together by that description, that summary, and then it tells you things like these are all the dog images and these are all the cat images, for example. So when we think of data, we can think of what you might otherwise think of data, things in a table format, but you can certainly have time series, things that vary in time. You can certainly have image data. And with every data type, you have to look at how that data is structured because the process you apply to it in order to extract these insights are going to be highly dependent on the data. And in fact, for any sort of data analysis problem, you're going to spend about 40 to 60% of your time looking at the data and thinking about the data. It's unavoidable. With that comes a study of the domain associated with the data. So if you were dealing with a data science problem, dealing with the power grid, smart meters, you're going to have to learn a lot about power generation, power delivery, excuse me, and power delivery. My voice gives out after an hour. So let me ask you, with a data science problem, maybe you've looked at the slides ahead of time, where do we begin? What do you think? Say, someone who haven't called them. How about you? Where do we begin? Where do you think? Mhm. You could look at the data. You've mentioned the loaded word variables. I'm glad you said that. Yes, you could look at the data, but you begin with a question, right? What is it you want from this data? For example, why do brownouts happen in this part of town? Why did Mr. Smith's heart rate peak or become elevated at 6 in the morning, right? Is this typical relative to Mr. Smith's baseline heart rate? And so you always start with a question, and thank you for, and I want everyone to put yourself out there. Don't be afraid to make mistakes, right? Thank you for answering. So you start with a question because this question guides what statements you're going to make, what visualizations you're going to try, what experiments you're going to run. So you always start with a question. So let's take a look at the process. So when you ask a question, this frames the problem that you're trying to solve. Because if you're looking at, does Mr. Smith's heart behavior, is this heart behavior normal? You have to know normal over what period of time? Over a day, over a week, over a month? What does normal mean for Mr. Smith? Or does normal, is that measured relative to all of the 60-year-olds, for example, right? And so you start with this question because that's going to frame ultimately the analyses and the insights you're enterprising to extract. And so after that, you then think about what sort of data you're going to pursue. The data is not always given to you. Now, in this class, many times, I will furnish the data, but in real life, you have to go out and construct the data or obtain the data, right? Now, that is also associated with all sorts of issues, especially in the medical domain. right? HIPAA, the privacy laws, federal law about medical privacy. There's also FERPA, federal educational rights to privacy, associated with your academic information. And so for certain types of data, there are laws and rules and regulations involved. And so the second step is to go out and pursue the data. What type of data do you need? How much of it do you need? How is it typically delivered? Along what time scale? All sorts of questions about where you go to obtain the data. And then you need to explore the data. That's where you look at the variables, and the variables are the individual measurements. And in this class, we deal with vector valued measurements. So thank you, I'm glad you said that. So you need to find and fix any anomalies or blemishes or issues that might arise in your data, because nothing is perfect in practical data. You have to deal with that messiness, and it's part of the data science process. Any questions? That make sense? Yes. Why? Okay. Ah, that's a great question. So sometimes there might be missing. So take, for example, a smart agriculture application. You have a bunch of sensors on a field and a farm, and one sensor might be measuring wind speed, one might be measuring humidity, one might be measuring nitrogen content. And these sensors sample at a certain rate, like one might be 5 times a second, one might be 10 times a second. Every once in a while, there's a hiccup and it just misses a measurement. But at the same time, when it's time to write out that vector of measurements and vector instantiation, you have to do something. So you just fill in, oh, this is missing, right? And so when things are missing, you just have an empty space for that particular position in the vector, and you have to do something data-wise with that. And there are all sorts of considerations that we won't talk about today. Another type of thing that might occur, you have a glitch and a sensor returns a measurement, but that measurement is completely off. And maybe it means for that sensor, it needed more time to warm up, right? For all of the circuits to warm up. And in the beginning, you get some errant messages, right? And these messages or these values might be too big or too small or just not make sense at all, right? And so you have to detect those things and you have to make a decision about what is an appropriate, notice I didn't say right, what is an appropriate course of action, because every course of action you take has a consequence, and understanding those consequences and its impact on the problem is really, really important. Okay, well, thank you for your question. Any other questions? Yes. Mm-hmm. Mm-hmm. Ah, you're not always, in that example, what you are looking for is an irregularity, an anomaly. But the question then is, how different should something be to be considered an anomaly? So for example, if Mr. Smith's heart rate, if that sensor measured, you know, 300 beats per minute, well, certainly a human being can't have a heart rate of 300 beats per minute. So something else must be wrong with the sensor apparatus. And so how you measure normalcy or typical is required in order to decide what does abnormal mean. And when you measure abnormal, right, this data cleaning problem that I was alluding to talks about detecting things that are missing, things that are grossly errors in the sensing apparatus, as well as for the real measurements, what is atypical for your real measurements versus typical. Does that make sense? All right. Any other questions? All right. And so you find and fix the blemishes in your data, and then you select your model. And you're going to validate often your model to make sure it's performing well, right? And there are various techniques for doing that. And after that, you communicate your results, and you're going to articulate them with an eye towards the audience targeted for your results. Now, in many data organizations, the folks that do the extraction of the insights aren't the ones that communicate to the audience. So for example, if you're working for the city of Worcester in the mayor's office, you're providing perhaps the mayor and the staff with these information, but you need to tell them what this information, these insights that you've extracted, what it all means for them to articulate appropriately to the consuming public or a public that has some training in the data sciences. Okay. All right. Any questions? No. And so this figure I found online, and I thought it was a great description of what data science is. The collection of data, that's the recruitment of your data, the cleaning of the data, fixing of your blemishes, the exploratory data analysis, that's the visualization and deciding upon what processes you're going to apply to your data, the building of a model, and the deploying of your model. Now, various jobs that deal with this, they call them different things, and this isn't the only nomenclature people use, and it really depends on the organization that calls it data science. But there are folks who deal with the collection and cleaning of data, right? Those are often in organizations like Amazon and Uber. Those are called the data engineers. And then there are the analysts. They do the exploratory stuff, the visualization and the slicing and dicing of the data, which will ultimately drive what model decisions that you're going to make. And then you have the machine learning engineers, folks that build these models that extract the insights and the considerations for these models, and they deploy them. And of course, the data science you could consider as someone who does all of these, but in most modern organizations, you don't typically have one person that does all of it. You generally specialize. Yeah. Any questions? No? Yes. That's a great question. It's ongoing, and the things you learn in the first few years, of course, industry, and I can say this because as an industry, the scale of the problems you deal with in industry, we just can't do in academia. We don't have the resources, computational, as well as the personnel. Take, for example, if you're doing analysis of satellite imagery, it's hard to get access to certain types of satellites if you're not in government agencies. In the beginning, you learn some of the theories and you learn some of the tools, but when you need to scale it up, especially to internet scale problems like Uber, you have to learn a little bit about parallel and distributed systems because you're going to be using some of those. And so to answer your specific question, you'll learn a sampling across these. And at the undergrad level, at the graduate level, you'll highly specialize in one or two of these. And in practice, it'll take you a couple years before you're fully productive. And when I say that, you're certainly making contributions from day one, but the level of responsibility increases over time. So you might be given responsibility for one particular feature in one module, and then the entire module, and then an area. But certainly along the way, you're going to be learning about the domain. So if you're doing data science for, say, CVS Health, right? You're going to be learning about health insurance business. You're going to be learning about the medical business at the payer insurance level, as well as about medical services. And so that learning about the domain, that never ends. But as you start out, you learn more and more and more. And eventually, the scale of what you're responsible for also grows over time. Okay. All right. Any other questions? No? All right. And so here are some data science jobs. And we have 4 more minutes left, 3 more minutes. And the takeaway from these, they're on the slide, is that depending on the organization, they're going to say data science means something different. We have John Deere on the left, CVS Health on the right, and I'll leave it to you to take a look at those. Here we have Spotify, the music streaming service, and they're trying to learn about the customer behavior and how to improve messaging to target the right messages to the right people at the right time. So you're trying to analyze the demographic based on the type of music they listen to and the types of choices they make when they click. Here we have T-Mobile. You're looking at business processes and how to optimize those business processes. So all sorts of organizations, some of them, when they talk about data science, they're really talking data engineering. Some of them, they're really talking about the machine learning engineer side. So this is just to make you aware that when you look for these opportunities, whether they're internship or you're on the job market for the seniors, to be aware of what data science means to that organization, because right now there's not one specific rigorous definition for what that means. Any questions? No? All right. So dealing with uncertainty and things that are messy is typically not the domain of computer scientists, right? We like to have things nice and clean, but when you deal with data, you have to be comfortable with when the atoms meet the bits, so to speak, when things get messy. And it's not to say that you must do this and you must do that. It's understanding what these tools bring to bear and when to use a tool and what the consequence of that particular choice is. And that's what the focus of this class is. And then you also over time, as I alluded to before, you need to develop some domain knowledge, and that happens over time because the data is inextricably linked to the domain from which it came. So if you're dealing with health data, you have to learn about the healthcare field. If you're dealing with power data, you have to deal with the power industry. You have to learn the domain. And so I would suggest, if you're interested in data science, that you choose something that you think is enjoyable. Because in my opinion, life is too short to do something you don't enjoy, right? Try something, look up some jobs. If you think you're interested in a certain domain, gosh, I'd love to do that, then I'd say go for it. And the nice thing about an internship is that you get to try out a different part of the country in a different domain without making the commitment of a permanent move. Okay, and so I had an example about spaghetti and meatballs, but I'm going to stop there because we only have about 2.5 minutes left. Rather than break in the middle of a new concept, we're just going to end there, and I will pick back up on Friday with the balance of today, and then also jump into the practical about PyCharm and the project one. Okay. All right. So with that, we'll end there. Have a great day. Welcome back. And I will see you all on Friday. You're welcome. Take care. You're welcome. Take care.